Today's lesson is over integers and graphing. In today's number routine, write today's number 4 different ways. Write problems using it as a sum, a difference, a product, and a quotient. Today's number is 12. So can you think of a sum that has a value of 12? 3 plus 9 equals 12. What about 14 plus -2 equals 12? Using negatives, we're going to be learning something. A negative whole number is called an integer. What about product? 3 times 4 equals 12. What about -6 times -2 equals 12? At Mimi's Junior High, we have communication between home and school through paw prints. That is a weekly newsletter. It's available online. It's an email sent to your parents about all the happenings at our school. Go Bobcats. And then we also have something called safety net. If you ever are feeling bullied by a student, by a staff member, you don't feel comfortable here, there is a form that you can fill out called Mimi's Junior High Safety Net. You can put it, it's anonymous. You put down your information down and you deliver it into one of the safety net lockers. There's a safety net locker outside of my classroom, room 117. We also have something called Hero Net. If you see a student who is a hero, who helped somebody, who did something, an unbelievable feat, please fill this part out so that student can be recognized during lunch. And advisory is a place where you, it's like study, where you study hall, you get to know your peers and you build relationship with your teacher and you get information about our school. Today you'll be assigned a textbook. Each student will be getting a volume 1 and a volume 2. Today, in the in the fall semester, we get volume 1. In the spring semester, we get volume 2. Each workbook costs $10. Please do not lose it. Please make sure you write your full name and your teacher name in the inside cover. Replacement cost is $10 per book. You must bring your ISN, your interactive student notebook, and your textbook every day to class. Today's homework is listed as the following. By the end of class, I will be able to graph an integer on a number line. You will be given a number line, you'll be able to graph it. And you don't even know what the definition of an integer is. So, ups and downs of shopping. Daniel is shopping at Macy's with many floors. He enters the store on the middle floor from the Skyway, and he immediately goes to the credit department. After making sure his credit is good, he goes up 3 floors to the housewares department. Then he goes down 5 floors to the children's department. Then he goes up 6 floors to the TV department. Finally, he goes down 10 floors to the main entrance of the store, which is on the first floor, and he leaves to go to Dillard's down the street. How many floors does Macy's have? So, let me get my pen, and I'm going to start drawing things. So we know that it is a multi-story department store. Daniel is shopping at Macy's with many floors. He enters the store on the middle floor. So let's say that this is the middle floor. From a Skyway. So there's another building next to it, and they are connected through a Skyway. So he immediately goes to the credit department. So this is called the credit department. I will abbreviate with CR for credit department. After making sure his credit is good, he goes up 3 floors. So it goes up 1 floor. He goes up 2 floors. He goes up another floor. So it's right here, goes up 1, 2, 3. And that is called the housewares department. Then he goes down 5 floors to the children's department. So he's right here in the houseware. He goes down 1, 2, 3, 4, Then he goes down 5. So 1, 2, 3, 4, 5. And this is called the children's department, CH. Then he goes up 6th floor to the TV department. Goes up 1, 2, 3, 4, 5, 6. And this is the TV department. Finally, he goes down 10 floors to the main entrance of the store. So right here at the TV, he goes down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, whoops. That's supposed to be doors. And that's the main entrance. And he leaves to go to Dillard's. How many floors does Macy's have? Most of you are going to put probably 11. Let's count. There are 1 floor, 2 floors, 3 floors, 4 floors, 5 floors, 6 floors, 7 floors, 8 floors, 9 floors, 10 floors, and 11. However, that is a mistake. Let's read it carefully. He enters the store. Let me get my highlighter out. Highlighter. He enters the store on the middle floor from a skyway. So this is the exact middle of the building. So if this is the middle, how many floors will be below it? 6 floors below it. So how many floors will be above it? 6 floors above that. So 8, 9, 10, 11, 12, 13. So there's 6 floors above it, 6 floors below it. This is the middle. Macy has 13 floors. So we are, if you do not realize it, we are practicing real life situation of integers. Integers are positive and negative whole numbers. We went up the elevator, we went down the elevator. So today we're going to be talking about 2 types of numbers, whole numbers and integers. Whole numbers are simply numbers that goes from 0, 1, 2, 3, 4, 5, and so on. As you notice, there are no fractions or no decimals here. So it's like counting numbers that include 0. So what is the largest whole number? What is the smallest whole number? Well, if you look at our number line here, we can tell our smallest whole number is 0. But from the number line, it seems like the largest whole number is 10. But be careful, there's an arrow. As you can tell, this arrow keeps going forever and ever. So there really is none. It's infinite. And it's represented with a sideway 8. So there really is no largest whole number. This number's going forever and ever. Our second type of number are integers. In 6th grade, we focus a lot on integers. Integers are like whole numbers, but they also include negative numbers, the opposites, but still no fractions and decimals. So we have our whole numbers from 0 all the way to 10 and keep them going. The opposite is on the other side. So if you have 1, on the opposite side is negative 1. If we're 2 spaces from 0, the opposite is negative 2, which is 2 spaces from 0. 5 is 5 spaces from 0. What's the opposite? Negative 5, because it's also 5 spaces from 0. 9, what is the opposite of 9? Negative 9, because they are both 9 spaces from 0. What's the opposite of negative 10? 10, because they are both 10 spaces from 0. So integers can be negative, positive, and even 0. Many students forget that integers include 0. So integers are positive and negative whole numbers, including 0. So list examples of whole numbers. I can say some whole numbers are like 5, 8, 15, 27. List examples of integers. 5, -5, because this is the opposite. -6, I'm going to say 6, because they're both opposite. So it includes positive, negative whole numbers, and it also includes 0. Classify these numbers in this chart. Is this correct? In this diagram, whole numbers are represented by the light gray. Are all of these whole numbers? I thought whole numbers cannot include fractions and decimals. So I will need to remove that one. Whole numbers is, I don't think -7, that's not a whole number. So 2, 8, and 0 are whole numbers. Any other whole numbers? 0 can be a whole number. 6 can be a whole number. 14 can be a whole number. And so integers. Integers are positive and negative whole numbers. Well, cannot be, that's a fraction. This cannot be, this is a decimal. Positive and negative whole numbers. -7, that's a negative whole number. I see positive, so it's a whole number and its opposite. So it could 14, so 14 can be a whole number. It can also be represented by an integer. It's part of both circles. 6 can be a whole number, and also it can be an integer. But can -7 be a whole number? No, that's why it has to remain on this outside. What we're going to be learning in a couple of days is something called rational numbers. Rational numbers are numbers that can be written as a decimal or fraction. It's really represented in a fractional form. This is 3 and 5/10, 9 and 7500, and 3/4. We're going to be learning that whole numbers and integers can also be represented as a fractional form, except for 0. All right, so whole numbers, integers. So brainstorm everything you know about number lines. So from this number line, what can you tell me about these number lines? Well, from what I can tell, 0 is in the center. This is going up. This is going down. This is positives going right. Negatives are going left. As we get away from 0, we are getting really, if it's a positive, if we're getting away from 0, we are getting larger. But if it's negative, you're getting away from 0, you're getting smaller. Is that really true? Let's see. If you're getting away from 0 and positive, you're getting larger. If you're getting away from 0 and negative, you're getting smaller. Generate a real-world situation for a positive integer. I'm sure there's... So can you think of some real-life situation where it represents a positive integer? For example, you can say, I gain 5 pounds. If you gain 5 pounds, how would you represent that? +5 or just 5. Generate a real-world situation for a negative integer. A football team had a loss of 9 yards. So that would be represented by -9. Another one, the plane is 30,000 above sea level. Above sea level. So it's 30,000 feet above sea level. That's positive. Or maybe say a submarine is 300 feet below sea level. To represent that, I put a negative. That is how to write it as a real life situation. So, for example, if you had a deposit is putting money into a bank account, so that's positive. If you withdraw, you're negative. You're taking money out from your bank account. Above is positive. Loss is negative. Higher is positive. Below is negative. Increase is positive. You fall, could be the stock market falling, is negative. Rise, less is negative. Decrease is negative. I spend money. Actually, if I spend money, I'm losing money, so it's negative. Less than and gain more than. I save $5. So that could be a negative because you're saving money. For example, you had a coupon and say save 50 cents. So that's negative 0 and 50 hundreds. So if something will cost $5 and you save 50 cents, that's only $4.50. And which of these are integers and which of these are whole number? Integers are, again, positive and negative whole numbers. We know this fraction cannot be part of it. And a whole number, opposite, whole number, positive and negative whole number, including 0. And here's 0. The left side is represented by negatives. -4 and -5. You have 2, -2, and so on. The opposite, if it's 34 spaces from 0, the opposite would be -34. -12 is 12. -2 is 2. So this is the study of integers and graphing.